Palo Alto Network's firewall. We're getting into VPN concepts now to tie things together with other networks in a very secure fashion. So there's really kind of two different ways or different types of VPNs on my Palo Alto firewall. Let me draw another one over here, I guess. I have a good way to do things. We'll say PAFW. Okay, that's the catchy acronym, by the way, for Palo Alto Firewall, just in case. So one of the things that we can do is looking at a site-to-site VPN. Okay, so tunneled connection, if you will, or site to multi-site, kind of a different way to do things. And this is going to be typically our IPsec side of things. The other part that we have is if I have a random user out here who wants to contact directly in, and that would be SSL VPN. So we'll call these users and call this one sites. I mean, I guess I could do it directly to a user IPsec also, but probably not the most efficient way of doing it from the user point of view, over configuration and all that stuff. From my certification perspective or my testing perspective, we need to be aware of the SSL VPNs, but not so much focus on it from a configuration or knowledge point of view. Most of what we're going to be looking at is going to be the site-to-site stuff, so my infrastructure point of view for how we handle VPNs. So that's just kind of the way that we happen to focus on here. Now, IPsec is really still the most common when people use the term VPN. It creates a tunnel from one side to the other where traffic is going to be authenticated and or encrypted. So there's different, actually there's many different nuggets in many other courses that we have here at CBT Nuggets that go through IPsec VPNs. So you may have run into this before. Good thing is it's a standard, and so there are RFCs associated with it. We'll see a number of them that have kind of been referred to over time. So like as an example, we have RFC 2401 to 4, which is just security architectures and stuff like that. We actually see that obsoleted because they do revise them every once in a while. The current version of that, which is our IPsec overview, is 4301. You may have heard of RFC 2409. Which is actually no longer used. That was my original IKE, so my Internet Key Exchange. And we'll go through the details of a lot of these in there as well. RFC 4306 was IKE version 2, which was obsoleted by 5996 and just recently changed to 7296. And so we made a lot of revisions, service packs, if you will, as far as the internet goes. Two other important ones that we have that really haven't been changed a whole lot, RFC 4302 and RFC 4303, which is authentication header and ESP, or encapsulated secure payload. So my two different types of authentication and encryption in IPsec. So those things are kind of very important as far as just our background goes on the whole wonderful world of IPsec. Now, from Palo Alto's point of view on things, I mean, I'd be familiar with them. I don't recall, when I did my CNSE, I don't recall being asked anything specific about what happens in this RFC number. So I don't think I get too stressed out about that, but it's good to know. It's also good to reference in case you want to go look something up, because RFCs, of course, are the standards, so the rules and regulations about how these things work, not just for Palo Alto, but for, pick your vendor, Cisco, Juniper, NetScreen, SonicWall, anybody who's going to do a VPN, all of these things in there, like I said, pick your vendor on there. We should follow the standards. And to know what pieces and parts are supported on each particular one gives us what we need to know on how to connect to somebody else. So that makes it very important in there to kind of get down to that. Now, with the way that we're going to do things, and again, like I said, I'll kind of put the SSL stuff to the side for right now and concentrate on the IPsec. So Palo Alto Networks, from an IPsec point of view, works with route-based VPNs. Okay, basically that means I have a network over here, whatever network that happens to be, and I have a network over here, and that's going to kind of determine where it is that we're going with it. So based on the destination of traffic, the tunnel or the endpoints is going to be placed into a particular zone, Okay, so this tunnel right here, where does it end up? Is it going to be on the outside? Is it going to be on my server zone? Is it going to be on a client zone? When traffic comes out of the tunnel, think about this as you're poking a hole into something. And, like kids, we used to play with, those expandable tunnels. They could fold up real nice, which parents love. But they could expand out and we could crawl through them and do all sorts of cool things. I used to love those when I was a kid. But this is exactly the same way. Where do you put the end of your tunnel? I'm going from the couch and I'm going to end up under the dining room table. Okay, cool. So those are my two zones. I have a couch zone and I have a dining room table zone. Two different sides, of course, two different firewalls that we're talking about. But if I come out of the tunnel into my dining room table zone, what things are my intra-zone traffic and what things would then be inter-zone in terms of how I'm routing, how I'm doing stuff? Okay? So kind of that's the part that we got to think of when we're building these VPNs in here is where am I going to put that endpoint? Where's that going to end up on here on both ends? Because my zones, my routing, my security policy, all of that stuff is going to occur there. We do have something based on this. So my route-based VPNs, a really important term to know is called proxy ID. And we will have a proxy ID per route that we happen to be talking about in there. And we'll be able to support multiples of them, and that's all well and good. But that's going to kind of tell us where we're going with things and how that's going to work. All right? So let me kind of go kind of step through a graphic on here and show you exactly what's going to happen from that packet perspective, where we're going to end up and where we're going to dump on things to see what's going to be going on. So we draw up a couple sites on here. We got site 1 over on one side, and site 2 on the other, kind of make things all nice and well and good. Give them some IP addresses as well. Let's go with site 1 will have 192.168.10, and then on site 2 we can go with 10.20.0.0. Okay, pick numbers, whatever they happen to be. And of course Palo Alto firewalls in between them. That's the important part, and connect over the internet. Now, when we decide we want to pull everything together and do an IPsec tunnel, that's our security decision, if you will. We do have to give tunnels numbers, so we'll see that tunnel.1 on there, and I'll get to that in kind of just a minute here for you. But when we start looking at this, we have our routing table, a route-based table associated with that, so we know, like everything else, what's the next hop. That's going to be our important piece. So when we create a packet down on site 1, and it looks at it and says, oh, the destination is 10.20. whatever, and I look at my routing table and look in there, I have an entry that says, ooh, that goes out tunnel.1. So in there, I know that I'm going to go through the IPsec process and push that into that tunnel, and it'll shoot out on the other end. And at that point, remember we talked about the zones, what policy do we have on the other side to know that traffic comes out of the tunnel, then it gets processed, incoming packet kind of thing, and where does it go? What does the policy allow? Does it get to the end point then? But over the internet itself, that traffic was secure. So that's kind of my overview process of this IPsec portion. Now, like I said, each tunnel is bound to an interface, a tunnel interface, if we will. This tunnel interface will exist in the same virtual router as the other networks that it needs to communicate with. So that's kind of the important parts that we have. Where did my pen go? Lost my pen. Okay, I found my pen, but I still realize that I've lost my mind. So anyway, routes bound to, we'll call it to our VSys. Okay, so our V router, if you will, virtual system in there. So everything that we have is going to work within that confine. I can't route to something that's not in the same virtual system as me because it's in a different routing table. So to the routing engine, a tunnel interface appears just like every other interface. It's a very simple decision. I go down the list and it's either there or it isn't. So all of these things that we have to do, need to have this tunnel interface there. Now each tunnel interface, and it's just a logical portion. We can create it however we want to, although keep in mind that is bound to the virtual system, so that may make a difference on your larger deployments, what's getting placed where. But each tunnel interface can have multiple VPN or IPsec tunnels bound to it. You don't have to do this. You could have them all be separate, and that's perfectly fine, as long as you don't exceed the number of interfaces that your particular model of the Palo Alto firewall supports. But it's just a way to go to reduce or to manage the number of overall interfaces. Different platforms have different limitations, by the way, in terms of what our number happens to be. So that kind of gives us the initial concept of where our tunnel stuff is going to be going on there. Now, time for a little review on IPsec in case you're going for those certification exams. Okay, so let me go ahead and clear this off, and we'll start over with our information here. Now, to set up an IPsec review, all of these things that we're going to do, our tunnel in here, there's going to be multiple protocols and multiple phases of communication. The first thing that we have is IKE, okay, which is our Internet Key Exchange in order to initiate a conversation. This is also called Phase 1. So Phase 1 is going to give me the basically just the two endpoints of my devices here. So let's call it FW. So from here to here, I need to be able to know to communicate with each other. It's peer ID functionality. So my local ID and my peer ID have to be set in order to figure this out. IKE, by the way, uses UDP 500. And on my outside interface here, remember those management profiles that we had, the management interface profiles? I do need to set this up so that IKE is going to be allowed coming in. Otherwise, you can send that to me all you want, and I'm going to ignore it because I don't care. Okay? So we do have to remember that part to be able to allow that to come in. And that could be one of those really frustrating things if you forget about it. That's called the I've been there and done that thing. So you should be able to learn from mistakes that I've made. It's always a good thing. Small things will come up to bite you in the butt, but that's the way that we start out in here. So my peer ID could be an IP address. It could also be an FQDN, the fully qualified domain name. Either way you want to go with it. If you have an IP address right here, well, either side, but your peer address right here, is it static or dynamic? If it's dynamic, I would absolutely, well, you kind of have to go with the FQDN. If it's static, you can really go either way. I guess it doesn't make too much of a difference. Personally, I go with the hard-coded IPs wherever I can, and something that you know is not going to change, because that way I don't rely on, is my DNS operational? Do I have any failure there, any problems, any hijacking, anything like that going on? One less thing for me to be concerned about. So IP addresses where you can, just kind of from a design standpoint. Now, what IKE is designed to do is create a secure channel. Okay? So our secure channel on here is for keys. Now that's kind of an interesting, I guess, philosophy, if you will. I have to use keys to establish a secure channel in order to transmit keys that we're going to then use to encrypt traffic. Huh. Well, we have two different pieces. And you'll see terminology used kind of in different ways. We have first what we call a KEK, which stands for a key encryption key. And then you also have, and I'll put it down here, a TEK, or a traffic encryption key. And you'll see the space difference here in a minute. But what we're getting into in my IKE Phase 1 is we're going to have an auth method, an authentication method that's going to be specified. It may be a pre-shared key in here. We're going to end up using Diffie-Hellman as far as doing a key exchange. So I'll go through that concept in just a minute on how we do that in there. And then we'll get into that symmetric key algorithm. So a key algorithm could be something, and we'll call this an encryption method, an encryption or key method, which is a number of different things that we have as far as our modes in there. This is also plus hashing. It's how we do our math and stuff like that. So my encryption or key method is going to be stuff like DES or triple DES or AES, things like that, different methods of AES. My hashing algorithm is going to be either MD5 or some version of SHA. And of course, the lifetime is going to go on here as well. All of these things, we'll say, I guess lifetime goes into it, but all of these things, my authentication method, my Diffie-Hellman type, my encryption key, and my hashing method must match on both sides. Give a different color here and say must match. So that's going to kind of give me all of my, what we call a transform set, but all of my methods of communicating in order to give me this in order to exchange keys about how we're going to do this. Now, the lifetime, like I said, is important on there, but even if we don't match on lifetime, the lowest number is going to win. So it's that part's not necessarily the end of the world. Everything else, though, must specifically match. We will find a couple other things that you may hear about of modes. You have a main mode or aggressive. They actually have to do with how many packets it takes to get through this phase right here. And typically what's going to happen is that I have main mode if I'm IP address to IP address, or aggressive mode if, well, they say that if it's dynamic on one end, but basically FQDN. Okay? So if I go by name, that's going to be tending what triggers that. In the Palo Alto world, we also have something called auto, which will determine by itself which of these two modes it's going to do. Many other vendors have that also, but it's there by default, and you just don't talk about it. It kind of is. So, but Palo Alto goes and calls it out. So you may see that there are 3 phases when you get to a certification exam: main, aggressive, and auto. So that gets us through phase 1 right there. So the next thing we're going to do is get into IKE phase 2. Now, interestingly enough, phase 2 is where we're kind of defining the tunnel itself. So we've defined a secure channel now, so are we able to talk? Are we able to get things going? But now I want to actually establish the parameters of the tunnel itself. So each side, we're going to do things in here like our proxy IDs. So know what's going from where to where. This is kind of defining what traffic is going to be going in there. There may be multiple proxy IDs going in there, but the bottom line is both sides have to inversely match each other. Now, this is important because one of the rules, so kind of back to my RFCs and my standards, it says that if I have this tunnel connection right here, and of course I've got a connection over the internet itself, so we already know that part. If I receive traffic through the tunnel, so it is encrypted, but it's not on my list, I look at it and say, well, this should not have been encrypted, I will throw it out. Likewise, if I receive something unencrypted, so via the internet, that according to my list should have been encrypted, I will also throw it out. So that's why it's important that the proxy IDs that we have, we'll call this an inverse match, so that we understand what each side is going to be doing on there, what they're going to be tunneling. Okay? So that's it could be specific networks, it could be a 0-0. It's completely up to your design as far as how that goes. In here, though, we're going to have some details as far as our IPsec type. All right, and this could be transport or tunnel. And typically it's going to be tunnel. That's my standard way of doing things. I do have a Diffie-Hellman part on here. Basically, am I going to be doing what they call PFS or perfect forward secrecy? I do have a key algorithm again, so an encryption algorithm and a hashing algorithm. So again, I'm into, DES, triple DES, AES over here. I'm into SHA or MD5 over here. And again, I'll have a lifetime. All of these things, once again, other than the lifetime, which will be lowest value, but all of these things must match. This, again, is my transform set for IKE phase 2. But what I'm getting out of here, phase 1 gives me my KEK, phase 2 gives me my TEK. This is what I actually use to encrypt the traffic through the tunnel. So when we start looking at this, and I'll get to the details in a second here about my Diffie-Hellman portion, when we start looking at things on here, this is a much more CPU-intensive way of doing things. It'll give me much more secure keys. But the reason is that these are the keys that derive these keys, so it's kind of like the master key. So it's really important to be super secure and extra math and all, however you want to look at it, to make sure that somebody can't compromise it. Because if somebody gets a hold of this, well, no matter what I come up with down here, we're pretty well hosed. So you got to kind of watch out for those. So looking at this, and I want to kind of go back, and I know we may have seen this before, but I want to show how some keys are exchanged from a Diffie-Hellman point of view over a public architecture where we can kind of get things going. So as we start looking at my keys, okay, so each side will start out, and we're going to have some shared seed to start with. In the IPsec world, this is typically my pre-shared key. Okay, it could be certificates or stuff, but it kind of gives us a starting point. That's going to, we'll just pick colors. I'll put yellow on that. Each side is going to have a private value as well, so its own personal certificate or personal setup for how to get things done on here. And what each side will then generate, so that's private key, is a public key that will be shared with the other side. Okay? So we'll pick two different colors, put red on one side and blue on the other one. Now each side will have our shared key and our private key is going to then generate a public key off of that. So yellow plus red equals orange, yellow plus blue equals green. That orange and green key, those public keys, can be exchanged over the internet. Now, there's kind of cool stuff to it. When we start looking at that in there, I don't necessarily care. There may very well be a hacker that's out there. I don't necessarily care that they intercept that information. Because these are hashed algorithms, I can't go backwards. So knowing the yellow and the orange and the green, okay, cool, have at it. Not much you can do about that. When I get the keys to each side, now I'm going to reapply my private key to that. Okay, so I'll take the received green over on the left over here and add my red to it, and I'll get my received orange over here and add my blue to it, and basically we'll end up with like a shade of brown. Okay, so each of that in there will have a equal key to start with, and that's going to be where we start. Now, into my Diffie-Hellman groups and things like that. So how much detail I put into this, because of course, colors makes it a very simple thing. We can kind of guess with the number of values that they are, which wouldn't be very secure. We're using big, huge numbers, big, huge prime numbers, by the way, and lots of stuff to it. In my Diffie-Hellman versions, that's going to tell me how many bits that I'm going to be using to seed this value in here. So how large my number happens to be. The larger, of course, the more secure, but also the more CPU and memory intensive it is to calculate the stuff. So while it seems like a great logical argument, because I can see you sitting there going, well, if it's more secure, why don't we use it all the time? Well, if we had unlimited CPUs or, magically this stuff happened, that would probably be a great idea. But we don't. So we want to process traffic in real time and do a lot of really fast calculations. We're going to use these just for the keys themselves, the key encryption key, so that we're only recalculating these things, once every 24 hours, once every 12 hours, once every 8 hours, whatever your lifetime happened to be in there for phase one. That's when we're doing the super secure stuff. My derivative key gives me my starting point to get my traffic encryption keys on the other hand, which is going to be less of a value. So based on like my triple DES, which is 168 bits, or my SHA, my AES values, which could be 128 bit or 192 bit or 256 bit. Those are the three values that Palo Alto supports right now. But it's going to be a lower number of bits, but a good algorithm to go along with it. So all of these things kind of give us starting points for how we're going to handle those things in there. Okay? But all of that comes from, getting my key encryption key and getting my traffic encryption key. So when it comes to the firewall, really all we have to do is just put the pieces together. All right, so kind of the things that we're going to be looking at in here. So first thing I do is create a tunnel interface. And it's just we're doing this on the network interfaces tunnel, okay, but it's just adding to a layer 3 zone and a virtual router just like any other layer 3 interface. Secondly, I'll configure IPsec. Now, what pieces do we need for this? All right, well, we know we need to have the local ID. We know we need to have a peer ID. I need to come up with a profile. I can either pick an existing profile, so remember those encryption and hashing algorithms that we had, or you can create your own. But remember, both sides have to match. So the defaults that exist in Palo Alto may not be the same as the defaults that exist in another vendor. So kind of watch out for that in there. If I have more than one policy transform set checked, I will keep trying them over and over until we come up with a match on stuff. Third thing I need to do after I get my IPsec pieces configured in there, and we'll talk about the multiple pieces there in a minute, but third, I guess I'll go ahead and put this down here, is to add routes, or just configure routing. So I can do static routes, I can do my dynamic routes, RIP, OSPF, BGP, whatever we're going to be doing in there, but I need to do something that's going to then tell my firewall, the routing part of my firewall, what goes out which tunnel to get to the other side in there. So pieces parts, and I have components. Hold, please. So my components that I'm going to configure in here are going to be an IKE gateway. So it kind of gives me things that I'm going to be moving back and forth from, point A to point B, my firewall over here, and see what's going to be in there. Okay, that's going to be my physical outgoing interface, my local IP address, my pre-shared key, stuff along those lines. I may also have, and these are more kind of advanced features for what we call DPD or dead peer detection, and NAT-T, which is NAT traversal. So if I have to do this over a NATed interface, then that kind of adds to the confusion for IPsec, but there are methods to get around that now. I also create my crypto profiles. So my network profiles, IPsec crypto would be where that is, and do this as needed. Basically for each section, encryption, authentication, Diffie-Hellman, any of those things in there. Lifetime can be in there. With my crypto profile for IPsec anyway, I could do it in length of time and in bytes transferred. So I have some kind of leeway as far as how I can do this stuff. And then, of course, create the tunnel, the binding itself that we talked about up here, kind of pull everything together for where we're at. I can do things in my tunnel, so we'll call it, we'll just say edit the tunnel. Because I'll bind my profiles and stuff to it, put the pieces together as far as what I have. I may also configure tunnel monitoring, which uses ICMP. So that way if you go, one side goes down, it'll actually get logged, it'll send an alert or things like that. You may have a specific wait recovery time, or you can fail over to a separate tunnel if that's available. So you've got some options in there that we can do in editing my tunnel. Proxy IDs can also be set up in the tunnel configuration. The default is 00, just simply overwrite it with anything that you may particularly need on there. You can, like I said, also use PKI, certificate-based things as well. A lot of governments require this. The certs tend to be a little bit more complex, I guess if you one word for it, but to figure out what it is that you want to authenticate on during the certificate chain. So that may be above and beyond where we want to get to. We'll just keep things simple for right now to get a basic site-to-site tunnel coming up. Right, so let's go ahead and look at those components again, how they feed into each other on here. Okay, so kind of the pieces, parts, and the flow of life, if you will, is looking at my information, my VPN tunnel components. I got my virtual router in my zone, which have already been configured in there. My physical interface already been configured, perfectly fine. My IKE Phase 1 gateway is going to be associated with this, because it's going to tie one physical interface to another one on the other side. I have an IKE Phase 1 profile, of course, that ties to this, telling me how that's going to work, which protocols or algorithms that I'm going to use. Likewise, down here, again, virtual router and zone for my endpoints, where's my logical tunnel? Where my logical interface going to exist? So this may be in my untrusted zone. This may very well be in a trusted zone. Like I said, servers, clients, DMZ, wherever you choose to end up putting that, where things are going to come out of the tunnel and be placed. So that's my IPsec tunnel, my IKE Phase 2, which I also have a cryptographic profile for. So that's kind of the flow of everything that we get to in order to get my tunnel set up and functional, which I guess would be my endpoint down here as far as working well. So a couple quick things on, I guess we'll call them errors. Potential pitfalls that we may run into in setting this up. And we'll kind of go with that. Okay. So once we start to see things, these are common configuration errors that may happen. So when we get to stuff, we'll call it, wrong IP, no connection. That's kind of a simple thing in here. What I see anyway, is timeouts during phase 1. So this is where my logging issues are going to be, that I basically don't see anything happening. I just see a timeout in there. I may also have in really, this could be phase 1 or phase 2, but we'll just call it no matching proposal. Okay, and this could be, like I said, could be a P1 or P2, and it'll specify which of them in there. But basically, that stuff, remember those things that all must match? Well, if they're not, this is the error that I'm going to get in there. Okay, so that's kind of the idea in here. We may also have a mismatched peer ID. And this simply happens when you pick a different address than the other side thinks it should be picking. So when my source IP address does not match your destination IP address, or vice versa. So everything in there from what we're configuring on either end must inversely match if we want things to work properly in there. All right, so that's kind of the interesting part for it. You may also have, and really more common one, is mismatched proxy ID. And this is very interesting. In some vendors, it shows up as a phase 1 problem, even though technically it's exchanged during phase 2. On the Palo Altos, it shows up as a phase 2 timeout, or not being able to find a matching tunnel. So there's a couple different errors that you may have on there for that. This, I would say, is probably the most common thing that people tend to run into, with just having things that aren't properly inversely matched, and so we can't set up the tunnel the way that we want it to. We don't have, so everything that we get, if everything matches in phase 1, we should get an IKE SA, or Security Association. If everything matches in phase 2, we should get an IPsec SA, or again, Security Association. So a lot of these things, if we find the errors in there, we won't get one or both of these, depending on which way we go. I can't get to phase 2 before phase 1 completes. And kind of one of those, logic of life sort of things. So we need to look at that, need to be aware of those. But again, these are just common errors that you or I may run into as we're dealing with things. All right, the great important stuff of IPsec VPNs, or I guess VPNs in general, but mostly IPsec from what we're concerned about. So we talked about all the fun things, moving from IKE into IPsec, both from a standards standpoint, as well as the matching pieces involved and the configuration pieces involved, what all we had to do to really get stuff started, I guess get stuff rocking and rolling, if you will, in terms of our configuration. So we had our IKE gateway up here. We had proposals or profiles. We also had profiles here, and the tunnel interface itself. So kind of binding all that stuff together. And what was that most important thing that we talked about? Right, and again, one of those common errors, I guess, as well, would be the proxy IDs. So those things, everything that we get to really has to match on both sides in order to create that secure communication. So that is that with VPNs. I hope this has been informative for you, and I'd like to thank you for viewing.